Welcome back to another segment of What's Up with Nick and Chuck. I'm Andy, the marketing guy from HUI. This week we are back with Nick and Chuck as we continue our conversation with Josh Talsky, industrial design. This week we will be talking about surface modeling when it comes to the industrial design. So with that, I'll send you to Nick and Chuck.
Hey everybody, welcome back.
Hey everybody.
Today we have back with us Josh Talsky, our industrial designer from last week, and also with us is Mark Collins, our applications engineer.
Hey guys.
How's it going?
How you doing, guys?
How you doing?
Thanks for joining us again today, Josh. We appreciate having you on the show. Now, would you be able to explain to us a little bit on why it's good practice to take and finish your concepts in CAD?
Sure. Yeah, no problem. Usually, for me, I start off with like 2D work. Either that's in concept sketching form or some other form, but eventually these things need to get made. And that's where CAD comes in. That's going to be able to be the bridge between the sketches and the final product that gets put on the shelves. So it's extremely important to get to that point with the designer so they can carry through their intent. And then eventually that gets handed off to engineering or manufacturing, and they'll probably manipulate that a little bit prior to going into production.
What type of direction does that provide, Mark, once a concept that's been finished in CAD gets to engineering?
Well, certainly, if you have a very aesthetic part, like a molded part, a big plastic part, a casting, a lot of times the industrial designer will put a lot of effort into making it look just right, where the engineer sometimes, makes a solid model instead of a surface model.
And then what is the difference between the two? What is that doing to that image?
Well, I guess a surface model's got complex curves, where a solid model is more of extrudes and cuts. So I don't know, Josh, how would you describe it? What's the difference between a solid and a
surface model?
Surface model, thank you.
Yeah, from my understanding of the way I look at it, surface models usually are a combination of surfaces that are trimmed and then knit together, kind of like like a backpack, different surfaces just knit together. The thing about SolidWorks or CAD modeling in general is that these surfaces, as far as the program is concerned, have zero thickness. So they're really not, at the beginning, they're not designed to go into production. At least from my experience, what I'll always do is take those surface models and then I thicken them or manipulate them in a way so that they can be transformed from a surface body to a solid body. So, even like a Coke can might have a certain 2 millimeter thickness on the walls of the aluminum. If you're going into production, you need to know that information. So that's where it comes.
So with surface modeling, who benefits from surface modeling? Is it the engineer or is it the client?
I would say both. The engineer, it depends on this. If as a designer, usually I'll be at the forefront of designing the aesthetics, and so it only makes sense that the designer would see it through as long as possible, so that the intent can be carried through by the same person or the same people. And before it's handed off to engineering, so they can use that information without having to recreate new stuff based on a two-dimensional sketch, for example. The surface modeling techniques is just another tool to use. It allows for certain freedoms that solid modeling may not, right off the bat. And so usually when you're talking about really complex products, maybe something like a bicycle helmet or a motorcycle, there's a lot of really intricate, detailed surfaces, very complex surfaces that are going on there that solid modeling isn't really intended for, from my experience. So if you have somebody who can create good surface models, a designer who can create good surface models, then it only helps your end product, both for the engineer and the client that is purchasing the surfaces.
So in the surface modeling, you can capture those details so that when they're solid modeling, those details are brought into the solid model. I guess
Sure.
Help distinguish the difference between the two.
You say that it's just another tool. So as you're making it, something's not quite right. You can push, you can pull, you can move stuff around, and then you get it. You get it just right. And then when you hand it off to an engineer, he might have problems with the model. He might start over in the sense where he's going to build it from the ground up, now knowing exactly what the end product is, and then he can lay those two over each other and find out where he needs to make some tweaks and changes. So in my opinion, it's more of the designer gets the aesthetics great and perfect, and the engineer gets the model great and perfect. Even though they might, at the end of the day, they should be almost the exact same thing.
So that kind of leads to the next question: is how much does an engineer actually use from the concept?
Quite a bit, if not all, right? Like, if you have a great model, it can be just brought in and used. But sometimes what happens, like, I know I don't have the best practices when I model, and so my tree can get quite long, and I have undefined sketches, and I have a lot of junk in my tree. And so a lot of times when I hand off a concept to like Dwayne or Greg on our team, they just start from scratch. And at the end of the day, they can overlay mine on top just to make sure that they got what I was trying to convey. But I guess, so they have a starting point and they have an end point. They know from the beginning what it's supposed to look like. And at the end, they can overlay it and say, hey, this looks really, really cool.
So Josh, and I guess Mark, if you could follow up to this question as well, when does it make any sense to surface model? Like, when shouldn't you do it?
If you don't need to do it, I guess that's when you wouldn't do it. If it's something simple, if you're just creating a tube, for example, you don't really need to go into surface modeling because it's going to provide you with less information at the end of the day, or you'll have a longer tree just trying to get it from a surface to a solid body at the end. You're much better off just going with, in general, when it comes to modeling, the quickest, easiest, and most accurate process available to you. So whether that be surface modeling or that be solid body modeling, you use it like a tool chest. Whatever tool enables you to get to where you want to be, that's where you go. For me, it would make most sense to utilize surface modeling when you have a really complex shape or complex surface that you're going to have to develop. Usually things like in SolidWorks, there's boundary surfaces and there's surface lofts that enable you to create really complex curvatures using different curves to develop a surface that patches between those two curves, or maybe four curves. That's when it would be most beneficial to use it. It's whenever you have really complex surfaces is when you would want to start getting into surface modeling.
I think another way to look at it is, if you have a design that's going to be really difficult to dimension or fully dimension, it's going to be a surface model. So, for example, like I've been playing with this glass paperweight, and if I wanted to make an exact copy of this, there's no way I can make this out of curves, or I should say, I can make them out of radiuses. These are going to be complex spline lines. And so this would be a perfect example of something that would have to have a surface model.
So from a OEM device manufacturer standpoint, right? Like, I don't know how many of our clients actually know about surface modeling and kind of the behind the scenes things that take place in concepts, but what should they be aware of, or what questions should they be asking before the concept stage to ensure that they're going to get the best design incorporating surface modeling?
An industrial designer, for me, that's never really a question that I've been asked. It's usually just how do you get to this point, and the industrial designer is kind of left up to figure out how to get to develop the product so that it's manufacturable. Like, what is the end goal for the client? So if they want a really complex thing, Mark was showing that blue ball earlier. I'm looking at a computer mouse that's definitely has a lot of surfaces in it, complex surfaces in it. you just know that as a designer that you're going to have to use surface modeling to build that. I think, but I believe what one of your questions was is when the designer hands this off, you want to make sure that the file type and the surfaces themselves can be read properly and they can be brought in properly. Sometimes I've seen STL or step files that are just very complex and somehow they don't get brought in, or maybe somebody doesn't know how to develop a clean tree, for example, and now it's very difficult for another person who receives that model to go back in and manipulate it if they have to. And then you also want to make sure that everybody who's involved is familiar with surface modeling techniques and knows how to manipulate these models.
Josh, that was a lot of great information. We thank you very much for your time on the show. How would people get in touch with you if they want to learn more about the services that you provide or doing some concept work with you?
Sure. Yeah, and no problem. Thanks for having me. The best way to get in touch with me would just be through my email, which is just Josh Talsky, one word, @gmail.com.
All right, everybody, at the bottom of the screen, you'll have access to Josh's contact information if you'd like to ask him additional questions or contact him regarding design services. And thank you guys again for tuning in. Thank you guys for joining us, Mark and Josh. And we'll see you guys next week on What's Up with Nick and Chuck. Take care.
Thanks, Josh. Thanks, Mark. Talk to you guys later.